Stuff. We're at the Babson Water Treatment Plant here in Gloucester. We're here with DPW Director Mike Hale. We want to let the residents of this city know what is going to happen with this plant, and that the city council did approve the loan authorization to make some upgrades to this plant. So here we are with Mike Hale, and Mike's going to explain the facility to us, and so we can get a better understanding of what's going on.
Thanks, Russell. The improvements are going to start all the way back to the reservoir, the water intake structure. Right now, we don't have the ability to take water at various levels of the reservoir. As the water warms up and the summer air is warmer, the water quality degrades, and so the best water quality is deeper in the reservoir. Currently, we can only draw water at one level. And also there are screens and bar racks that prevent debris from coming into the facility, which just make it more difficult to treat the water. Those bar racks, screens, and the level controls don't work. So this is one element of it. Also, as the raw water comes into the facility, we can't control the flow as well as we'd like to. Likely one of the causes of the plant's malfunction this summer was the volume of water that rushed into the sedimentation basins. The ability to control it will allow us to have water come in gently versus a big surge. I mean, the surge that was reported to this summer jumped from the equivalent of 3 million gallons a day to 6 million gallons a day in an instant. That's just the water rushing through 24-inch pipes right into the facility. So it's really wholesale. It's from the raw water intake into the facility, underneath us right through this area. The back wall, all the way out to the far end of the facility here, we have sedimentation basins, 197 feet long, 64 feet wide. There's two sections, 32 and 32. That's where the primary settling happens. That's where these chemicals are added at this facility to separate the water from the organics, the color of the water. If you look at Babson water just in a clear glass, it's tea color, it's golden color. There's a lot of mineral buildup to it. It's just a natural color of our water. These chemicals separate that out before it reaches our filters. We're looking at new chemicals to optimize water quality getting to the filters. The more organics we can remove before the finished water, the better quality water we'll have. This is the same technology that's been used here since the mid-60s. It's time to take a look at something a little bit more modern. As you can see, nothing's automated. These dry chemical feeds, if you have an issue, you have a pretty common tool to help move it through the system.
So this is like a bread maker.
A big flour sifter.
Big flour sifter.
So as we put the sodium bicarbonate through the system, it goes down into these feeders. You can see where it gets plugged. You can see where there's chances for operator error. Nothing is automated. It's all manual. Right. The line feed is the same technology, or lack thereof technology. We had polymer. We have our Allen feed right there, which is probably the most modern piece to this facility.
All this has changed.
All this will be improved, exactly. There's still some question exactly what it's going to look like when we're done. That'll be determined by a pilot program we're doing right now on the chemical optimization of the facility. Whatever works best for us, we'll use here.
It'll stay. Do you think it'll stay a powdered mix, or is it going to go to a different type of gas?
No, we're certainly getting away from gas. That's one thing we did at West Gloucester last year. West Gloucester is still using a gaseous form of chlorine. Very dangerous for neighbors, very dangerous for operators. We went to a liquid chlorine, which is actually flow paste over there, meaning the operators don't have to try to calculate how much water is leaving the facility or being processed through the facility. It's done automatically. They're still always checking it every 15 minutes, but it leaves less chance of operator error. We still may have powdered forms here. I don't see us getting away from that completely, but the idea is to have a more efficient chemical treatment process for better water quality. So this is another phase of the work that's being done. Within these sedimentation basins, there are automatic collectors that as the sediment settles to the bottom, all that sediment's pushed to the end to be disposed of either to the sludge lagoons or the sanitary sewer. Currently, the automated system doesn't function as well as it should. There are a number of big chains with scrapers that pull it all. Some of those chains are broken completely. Some of the scrapers are missing, so it becomes a very labor-intensive effort to get in here during the off-season and manually push this sludge 197 feet to the end so it can be disposed of. And that sludge could get, 4, 5, 6 feet thick at the end of the season. It's very deep. I can show the camera down